Welcome to Educator.com. This lesson is about solving multi-step equations. In this lesson, you will learn to solve multi-step equations. Applications are for modeling and calculating more complicated problems. Let's go over some vocabulary. Some of it may be review. Like terms are terms that have exactly the same variable factors. We talked about this in the last lesson. For example, 3a and 7a are like terms. However, 3ab and 7a are not like terms because they don't have exactly the same variable factors. In 3a and 7a, they both have a. But in 3ab, there's an extra b compared to the 7a. The distributive property shows how multiplication affects addition or subtraction. So for example, we have the a out front, and I like to think about it as if you're distributing the a to the b and the c. So we end up with ab plus ac. So it's showing how multiplication affects this addition. Yes, you're adding the b and the c, but you're also multiplying by a. So it could also be ab plus ac. The distributive property can also be used with subtraction. So for example, you could say AB minus AC. And you're giving the A to the B and the A to the C. We're going to use the distributive property to simplify an expression within an expression. Let's try simplifying before solving an equation. So first, we want to collect like terms and make each side as small as possible before we start using inverse operations and canceling out terms. So before, we might have started with subtracting 45, the inverse of adding 45, and then adding 12x, the inverse of subtracting 12x. But what we're going to do first here is combine any like terms in order to make the left side as simple as possible before we start solving. So I've circled 8x minus 12x to show that they are like terms. As your equations get longer or your expressions get longer, it's very helpful to circle the like terms so that your attention can be focused on the terms that can be combined. 8x minus 12x is negative 4x, so I've used up those two. And then I still have plus 45 equals 9. So now this has become a two-step equation, which we've done before. So I'm going to subtract 45 from both sides. That's the inverse of adding 45. That goes to 0. It's canceled. I only have negative 4x on the left. I'm a step closer to isolating the x, getting x alone. And 45 minus 9 is 36. And the negative 45 was larger, so it's going to be a negative 36. And now the inverse of multiplying by negative 4 is to divide by negative 4. Negative 4 divided by negative 4 cancels to 1, and 1 times x is just x. And negative divided by negative is a positive, and 36 divided by 4 is 9. So my answer is a positive 9. Remember that you can always go back and check your answer by substituting in your value for x. Over here we see we have two sets of like terms. The 6b minus 3b is my first set, and I could have negative 15 equals 6b minus 3b is 3b. And then we have another set of like terms. The positive 12 plus 6 is plus 18. So look at how much shorter I've made my equation. Just by combining like terms, it now has become a two-step equation, which is a lot simpler to solve than going in and reversing 1, 2, 3, 4 steps singly. Now we only have to reverse or inverse 2 steps. The opposite of adding 18 is to subtract 18, and I'm going to do that to both sides. So now we're going to add, because the signs are the same. 8 plus 5 is 23, and then we have 1, 2, 3, 4. Negative 43 equals 3b. And we're going to divide both sides by 3. Cancels. B equals negative 43 over 3. Or maybe you want to put it into a mixed number. 3 goes into 4 once. And 3 will go into 13 4 times, leaving 1. So B equals negative 14 1/3. Let's use the distributive property and let's set up our own equation. Your class hopes to collect 120 pairs of shoes for Haiti relief efforts. During the first week of the drive at your school, the 24 students in your class bring an average of 3 pairs of shoes each. For your class to reach its goal, how many more pairs of shoes does each student need to bring? All right, well, let's go through and see what the question is again. For your class to reach its goal, how many more pairs of shoes does each student need to bring? So we're going to be looking for how many more pairs of shoes. We know our goal is to reach 120, and we have 24 students that are bringing in shoes. And so far, they've brought in 3 pairs each. So that would be 24 times 3. And 24 times 3 is 72 pairs of shoes. That has not quite met our goal of 120. So they need to bring in additional pairs of shoes. So I'm going to say plus A. And A is going to represent additional pairs of shoes. And look at how I've set up this distributive property. Because yes, the 24 students have already brought in the 3 pairs equaling 72, but the 24 students need to bring in some additional shoes. So let's distribute this. 24 times 3 we found is 72, and then 24 times A is 24A. And that will get us to our goal of 120 shoes. We don't know the additional that each of the 24 students need to bring in, so that's why that's our variable. Let's take out the 72 pairs of shoes that we've already gotten because we don't need to worry about those. We already have them in hand. 10 minus 2 is 8, we borrowed, and 11 minus 7 is 4. So the 24 students need to bring in another 48 pairs. Let's divide by 24 and see how many each student needs to bring in. And A equals 2. So each student needs to bring an additional pair of 2 pairs of shoes. But let's go back to our question because that's not answering our question. It says for your class to reach its goal, how many more pairs of shoes does each student need to bring? Well, yes, each student needs to bring 2 more pairs. So now we've answered our question, 2 more pairs. If you just leave it simply as A equals 2, in a word problem, you don't know which part of the word problem you're referencing. So remember that in a word problem, you always need to include your units. And perhaps the question might have asked, how many total pairs of shoes does the student need to bring? Then you would have had to take the 2 and add it to the 3 that they had already brought. So it's very important that in a word problem, especially the ones that are becoming more and more complicated, that you go back and make sure you've answered the question correctly. Let's try using the distributive property to set up another equation. Your group of friends goes to an amusement park. Admission is $10 for each student and $15 for each adult. The total cost is $380. There are 12 girls in your group and 6 adults on the trip. How many boys are in the group? So we know that there's a combination of boys, girls, and adults on this trip. And we know that the total cost for all 3 of these groups is $380. We know that we have the 15 adults. I'm going to say adults is A, girls is G, and boys are B. So for adults, we have 15A because $15 for each adult. And then we have $10 for each student. But we know that there's 10 for the girls, so 10G. But we also want to know the boys. And the boys are also going to be 10 because those are the students, 10B. Okay, so we've set up a rough equation here. The problem with this equation is none of our variables are the same. So in that case, we need to set them all the same. Well, if you notice, the cost is already differentiating between adults and students for us. So we could just call all of these P for people. So $15 for the adult people, and we know that it's adults because of the 15. And then we have 10 for the girls, and then we have 10 for another group of the boys. So we have $10 for the girls plus the boys. Well, don't we already know the girls? The girls are 12. So we have $10 for the 12 girls is $120 for the girls. And the remaining is going to be 10 for the boys? Well, we already know for the adults as well that there are 6 adults. So I can put that number in once I multiply it. 15 times 6, we have 30, and 690. So $90 for the adults. Because we knew the exact number of adults. There were 6 adults at $15 each was $90. And then we knew that there were 12 girls. 12 girls times $10 each is $120. So the only thing missing is our P for boys. The P amount of people, which are boys. And that's going to equal $380. So let's take out the money that we already know about. I'm going to combine 90 and 120, and that's $210. $210 have gone to the adults and to the girls. So let's subtract that. So 10p. So the only thing left over is the money that's been spent on the boys. 80 minus 10 is 70, and 100 minus 200 is 1. So the amount of boys are being paid for with $170. So let's divide by $10 for each boy. Can cross out the zeros. So each boy is paying $10, and if you divide the 170 by 10, you get 17. So how many boys are in the group? There are 17 boys. Remember to come back, read the problem, and include your unit, boys. You want to make it clear that you're not talking about the girls or the adults or all the people, but in fact you're talking about the boys. Let's try an extra example here. We're going to be collecting like terms and then simplifying. 3c plus 11 minus c plus 5 equals 78. 3c minus c is 2c. Use those up. We have 11 plus 5 left over. That's plus 16. So now we've gotten it down to a two-step equation. Subtract 16, subtract 16. 2c equals 8 minus 6 is 2, 7 minus 1 is 6. And now the inverse of multiplying by 2, divide by 2. C equals 31. Remember that you can check these equations by going back and substituting the values. Here we're going to be distributing a negative. Remember that we talked about when distributing a negative, you have to be very careful that your signs are going to change. So negative 2 times x is negative 2x. A negative times a negative now becomes a positive, and 2 times 9 is 18. So this is the tricky spot here, making sure that you remember the negative and the negative will become a positive. And now we're back to a two-step equation. Subtract 18, subtract 18. Over here, our signs are the same. When signs are the same, you're moving in the same direction on the number line, so you're going to combine your numbers. 8 plus 4 is 2. Or 12, and we carry the 1, and we have 4, negative 42. Now, the inverse of multiplying by negative 2 is to divide by negative 2. So I'm going to divide both sides by negative 2. Negative divided by a negative is a positive, and it's positive 21. Here, I'm going to be working with a fraction and distributing. All right, so remember that with multiplying fractions with whole numbers, it's really as if you're putting the whole number over a 1. So 2 becomes 2 over 1 times 3 over 2. These 2's can cross simplify and you get 3 over 1. If you're not sure what I just did there, you can think about it like this. 2 times 3 is 6, 1 times 2 is 2, and 6 divided by 2 is 3. So what I did lastly was to divide by 2, or you could cross simplify and divide by 2 early on. And your answer is 3. So we have 3x, and now I'm going to distribute the 2 to the 4 plus 8. And I'm going to recopy everything else, not using it. Oh, you know, we can't have different variables here and solve for the variables. So I'm going to say that this is an x. Of course, you can't change it in your problem like that, but I was setting up these problems, and that should be an x. Otherwise, you can't solve. All right, so 3x minus 6x is negative 3x plus 8 equals negative 7. And now we're back to our two-step equation. The opposite of adding 8 is to subtract 8. And negative 3x equals negative 15. Divide both sides by negative 3. And x has been isolated and equals a positive 5. Let's try setting up an expression. You mailed 3 identical letters weighing more than 1 ounce each. Mailing each letter cost 39 cents for the first ounce, plus 24 cents for each additional ounce. Each letter required $1.59 postage. How much did each letter weigh? All right, so there is some extra information here that we don't need to know about. It says that each letter required $1.59 postage, and they're talking about mailing 3 letters. Well, we don't really need to know about all 3 letters. We only need to know about 1 letter because we're really only looking for the total of 1 letter. So I'm just going to think about 1 letter. I don't need to worry about all 3. And I know that I paid 0.39 for the first ounce plus 0.24 for each additional ounce. So the flat rate is 0.39. And then there's going to be some additional money. So we're thinking about the ounces. We could say total ounces equals T. It's probably not a good idea to use O for ounces because it looks like a 0. So the total ounces is T. Well, we're already paying for 1 ounce at 39, and then the rest of it is going to be 24 cents per ounce. But we've already paid for 1, so I'm going to subtract 1 of the ounces. See, this is the total number of ounces. We've already paid for this 1 ounce by giving the 39 cents. So I don't need to pay an additional 24 cents for that ounce. So be careful to subtract that ounce so that you don't get double charged for it. Equals 159. All right, now let's go ahead and solve this. I'm going to be distributing the 0.24 and distributing the 0.24. So 0.39 is for the first ounce, plus 0.24 for each additional ounce, minus the 0.24 for that ounce that we've already accounted for here. I can combine my like terms, which are the 39 cents minus 24 cents, and that is 5. So 15 cents. So we have 0.15 plus 0.24 T equals 159. Now, it's a 2-step equation. I can subtract my numbers, 0.15 cancels out. I have 0.24 T equals 9 minus 5 is 4. 5 minus 1 is 4. And 144. And now I'm going to divide by 0.24. Cancel that out. T equals, let's come over here and do our division. It's going to be 1.44 divided by 0.24. We move our decimal over twice, so do the same on the inside. 24 won't go into 14, so I have to take an estimated guess. I'm going to say about, well, 25 will go into 100 4 times, and then 44 is almost 50, so I'll say another 2 more. So let's say a total of 6 times. 6 times 4 is 24, looking good. 12, 13, 14, perfect. So T equals 6. So the total ounces is 6 ounces. And let's go back and check our question and make sure it's not asking how much additional ounces there were. It says how much did each letter weigh. So we wanted the total ounces for 1 letter. So we're going to say each letter weighed 6 ounces. So remember to include your unit. Thank you for watching educator.com.